Okay, it's me again, and today we're going to be doing 9-7, factoring special cases. If you can, please remember back to when we multiplied special cases. I don't know what I'm writing here. It should be cases. Oh, this is not going to be stellar. Okay, so factoring special cases. When we multiplied special cases, we were multiplying perfect square trinomials or squaring binomials to get to the trinomial, and then we were also finding the difference of the binomials and making and finding those results. So here we're going to basically be undoing what we did. So we're going to start with perfect square trinomials. So let's just look at these equations and see what we're talking about. We've got x squared plus 8x plus 16. What I want you to look at is the first term and the last term. Okay, obviously we're squaring the first term, and your c term, your last term, should also be a perfect square. In this case, hopefully you will recognize that we end up with x plus 4 squared. Okay, I really just want you to make it as easy as that. Okay, looking at another example where we have n squared minus 16n plus 64. Okay, realizing that with this negative here, we have a square here, perfect square here. So this is going to be n minus 8 squared. And that is it. That is as simple as this becomes. And so I need you to be aware of the fact that you can make it more complicated, but you shouldn't. Now let's say that we've got an a in front of our x squared. Let's look at 9g squared minus 12g plus 4. Okay, we're going to know that this is a perfect square trinomial by looking at the fact that this is a perfect square and this is a perfect square, as well as our c term is a perfect square. You have a negative here, so the square root of 9 is 3, the square root of g squared is g, and we've got negative or minus, square root of 4 is 2. So this is quite simply 3g minus 2 squared. Okay, one more. 4t squared minus 36t plus 81. Perfect square, perfect square, perfect square. So this comes out to 2t minus 9 because of this squared. Okay, and these are called, again, perfect. Look, I can't even spell that. Perfect square trinomials. Okay. Please make these as simple as I just did. Okay. Our next special case that we are going to work on is the difference of squares. That was something that we also did when we multiplied. If you remember, when we were multiplying and we had, let's say, x plus 1 times x minus 1, this just, when we multiplied that, when we FOILed it, it came to x squared minus 1, because your middle term, oh, you can't see that, look at that, there we go, oh, there it is. Okay, so our middle term is gone. If we actually FOIL it, we see that we've got x squared plus, let me see, our outside is actually minus x, and then our inside is plus x, and then our last is minus 1. And obviously negative x, positive x combine to 0, so it becomes x squared minus 1, which is what we have here. So that's what we were doing. So now we're going to undo that, okay? So our problems are going to look like x squared minus 36. So we need to be able to look at that and realize there is no b term. Okay, this is a perfect square. Okay, this is a square. So we have to know that this is x plus 6, x minus 6. This is just a visual. You have to be able to look at that and see it. Now let's put a term in front of it. Let's say 9v squared minus 4. Okay? Let me point this out. Perfect square, perfect square, perfect square. So this becomes 3v plus 2, 3v minus 2. Let's do 25x squared minus 64. Again, perfect square, perfect square, perfect square. No b term, no middle term. So this becomes 5x plus 8 times 5x minus 8. Okay, in all cases, you can go ahead and check your work by foiling. Okay, this is 25x squared. Outside is minus 40x. Inside is positive 40x. And our last is negative 64. This in here becomes 0. So you are left with 25x squared minus 64. Okay, the last thing that we are going to look at in this section is if we can factor out a common factor before we separate it into binomials. So we're going to look at 8y squared. Oh, you're not going to be able to see me again. There we go. 8y squared minus 50. Now, it has no b term, but there are no perfect squares here either. However, I know that I've got a common factor of 2. So the first thing I'm going to do is pull that 2 out. I've got 4y squared minus 25, and now I have the squares that I need. So this becomes 2 times 2y plus 5, 2y minus 5. Okay? And in complete factoring, do not forget that that monomial that you are pulling out. Okay, so let's go ahead and look at a couple more of these. 3c squared minus 75. Okay, again, you have no b term, so you're thinking this should be the difference of 2 squares, but I'm first going to have to pull a 3 out, giving me c squared minus 25. And then you can see easily that it's 3c plus 5, c minus 5. Okay? And finally, my last example is going to be 28k squared minus 7. Okay? Once again, no b term, so I'm looking for something else. I can pull a 7 out, giving me 4k squared minus 1. Okay, which is going to give me 7 times 4k plus 1 and 4k minus 1. Oh, Lord. Okay, sorry. Once again, I really need to have somebody watching over me at all times, okay? Because this should be a 2, and this should be a 2, and there's my 1. So putting my nice line through it so that we can see it better. 7 times 2k plus 1 and 2k minus 1. Okay, there you go. So hopefully you find this not too complex, and we will work on problems together tomorrow.